Let's solve this question. It seems the harmonic mean of the roots of the given quadratic equation is equal to 4. Then we need to find the value of b. Now, comparing the given equation with a quadratic equation, I can say the value of a is equal to 5 plus root 2. The value of b is minus b, and the value of c is 8 plus 2 root 5. Now, if alpha, beta are the roots of the equation, then the harmonic mean of the roots will be 2 alpha beta by alpha plus beta, and it seems is equal to 4. Now, 2 1s, 2 2s. Alpha into beta, product of the roots is c by a. So, which will be 8 plus 2 root 5 divided by 5 plus root 2 whole divided by alpha plus beta. Sum of the roots is minus b by a, that is minus of minus b whole divided by a, which is 5 plus root 2 must be equal to 2. Now 5 plus root 2 and 5 plus root 2 gets cancelled out. So we get 8 plus 2 root 5 by b is equal to 2, or b is equal to 8 plus 2 root 5 by 2. And if I cancel 2 throughout in numerator and denominator, we get the value of b as 4 plus root 5, which is answer option B. Definitely an easy question, and someone can answer provided they have the understanding and knowledge of how to identify a harmonic mean of two given numbers. And the moment they see alpha beta and alpha plus beta, we need to substitute the value of product of the roots and sum of the roots. Now let's see this question at hand. If the difference between compound and simple interest for a certain amount of money invested for 3 years at an annual interest rate of 10% is 527, then we are to find the amount invested, which is nothing but principal. Now, if we apply the formula of compound interest and simple interest and equate the difference to 527, we might be able to get the answer, but the calculation is quite cumbersome. So in such situations, it would be helpful if we assume a principal and calculate the difference between SI and CI and accordingly compare it with the difference given in the given question. Let me explain by what I mean so. Suppose if I consider the principal to be 1,000 rupees, rate of interest is 10% and time period is 3 years. Now, simple interest, compound interest for the first year, for the second year, for the third year, and of course the total. Now we know simple interest is same for every year, which will be on the principal, that is 10% of 1,000, which is 100. So the total simple interest becomes 300. When it comes to compound interest, interest is calculated on principal and on interest generated till then. So compound interest for the first year is 10% of principal, that is 100. For the second year, it is 10% of the principal, 100, plus 10% of the first year's interest. So 10% of 100, which is 10. For the third year, the compound interest is 100 rupees, which is on principal, plus interest on first year, that is 10 rupees, plus interest on second year, which is 11 rupees. Hence, the total compound interest for all the 3 years is 331. And if you observe, the difference between SI and CI is 31 rupees. Let me show you how we can use this by the property of comparison to find the principal in the question. So, If the difference is 31 rupees, the principal is 1000. If the difference is 527, how much will be the principal? Which is 527 by 31 into 1000. So which is equal to 17,000. Answer option B. Now this question also has a small risk factor involved. Even after getting the answer as 17,000, you need to be careful because option B and option C have just a difference of 0, but start with 17. So in the rush, there is a good chance that you might mark option C, which is not the right answer. Now let's see this question. The minimum number of times a fair coin must be tossed so that the probability of getting at least one head exceeds 0.8 is. Now, what I want is probability of getting at least one head, which, if you observe carefully, can be written as 1 minus probability of getting all coin tosses showing tails. I repeat, when I toss a coin certain number of times, the probability of getting at least one head is nothing but 1 minus probability that every time it shows a tail. And I want this to be greater than 0.8. Suppose if the coin is tossed n times, then the probability that every time it shows a tail is 1 by 2 whole power n. Now, probability of a tail showing up when a coin is tossed once is 1 by 2. So if I toss a coin n times and every time I want it to show a tail, then the probability is going to be 1 by 2 whole power n, which must be greater than 0.8. So from here, I can say minus 1 by 2 whole power n must be greater than minus 0.2, multiplying with a minus 1 throughout. Of course, the inequality sign flips, and I will write 1 by 2 as 0.5 whole power n must be less than 0.2. Now, substituting n is equal to 1, 0.5 is not less than 0.2, n is equal to 2, 0.5 whole square, 0.25 is not less than 2, and n is equal to 3, 0.5 whole cube is 0.125 is less than 0. Hence, the minimum value of n that satisfies the given condition is 3. Hence, answer option C.